Depletion of energy sources. In order to get energy into our body, we eat food. The fats in the foods are broken down into fatty acids, and the proteins in the food are broken down into amino acids. The carbohydrates in the food are broken down into glucose, meaning that ATP-PC can be created, which is then broken down into energy and used in the slide-in filament theory, allowing our muscles to contract. This means that the more carbohydrates that we have in our food, the more ATP-PC will be created, which is why lots of long-distance runners will eat more carbohydrates before the race, which means that they will be able to run for longer. The amount of glycogen in our body decreases when we exercise. This means that we have to use fats, meaning that we cannot go as fast as usual, causing us to fatigue. Phosphate creatine is our source for ATP, as we break down PC to create energy, to then bond PC with adenine diphosphate to create ATP, which means that we can use ATP for the slide-in filament theory to make our muscles contract. However, our PC begins to run out, which means that we have to move on to a different process which doesn't involve PC. This means we then move on to lactic acid system. The lactic acid system uses glucose and glycogen instead of PC. However, the lactic acid system is a much longer process, meaning our muscular contractions are slower, causing us to fatigue. After a while, we then begin to run out of both glucose and glycogen, meaning we have to move on to a different process. This process we move on to is the aerobic system. The aerobic system is still using glucose and glycogen, but also oxygen and fats, which we use as another energy source, which is even slower than using the glucose and glycogen, meaning that this system takes even longer for our muscular contractions to happen, making them slower, resulting in even more fatigue. Effects of waste products. When exercising, our body's acidity levels increase with things such as lactic acid and carbon dioxide. When our acidity levels increase, our bodily functions cannot work as quickly, meaning processes such as the Krebs cycle and ATP-PC system will not function as quickly because our body moves on to the lactic acid system and then the aerobic. The process of making ATP takes longer to create, resulting in our body to fatigue. Neuromuscular fatigue. During exercise, our body has a depletion of acetylcholine. This means that the neurotransmitter that tells our muscles to contract cannot work as quickly due to there being less of it. This results in fatigue as our neurotransmitter is telling our muscles to contract at a slower rate. There is a reduced calcium ion release during exercise. This means that the reduced number of calcium ions results in slower contraction rate as they are used in the slide-in filament theory, meaning that with a reduced number of calcium ions there is a reduced number of muscular contractions, causing us to fatigue. Excess post-exercise oxygen consumption, or EPOC, is a recovery period after exercising or physical activity when we are still breathing heavily after finishing it. EPOC is a recovery period that is intended to recover the oxygen lost during exercise and erase the oxygen deficit. Fast components. After exercising, we need to restore the muscle's phosphagen stores in our body as they would have been all used up. We restore our muscle phosphagen stores by using oxygen. This is done in the EPOC recovery period, which can take up to 3 minutes. After exercise, the build-up of lactic acid is removed by oxygen. This is because lactic acid causes cramp in our muscles, so it needs to be removed and does so within the EPOC recovery period. Slow components. During exercise, our myoglobin stores use all of their available oxygen to the working muscles to allow them to function. This means that when we finish, we will need to replenish them, and we do so during the EPOC stage as we breathe heavily to replace the oxygen that was lost in the myoglobin stores. We also use up all of our glycogen in our body, which means we will need to replace the loss of that, and we do so by eating food and breaking it down to replenish the glycogen that was lost in our body. This could take up to a couple of days depending on the amount of glycogen that was lost.